Hi guys, a very warm welcome to this web series, which is on a very interesting topic: machine learning fundamentals. Uh, we're kickstarting this particular series, which will be talking about the fundamental concepts of machine learning. This particular web series, will be uh, specifically helpful. It will be very useful for students who are in BTech, BTech computer science students. It is useful for other specializations because they are using machine learning in a variety of different specializations. Machine learning is being used nowadays. There's hardly any domain where machine learning is not utilized. It is not only useful for students of BTech level, but otherwise as well, because we'll be discussing fundamental concepts, very basic concepts of machine learning. It will be useful for professionals who belong to different domains, who have not yet gone into machine learning, and they can just start from here and grasp the basic concepts of machine learning, and they will be definitely useful for them going forward with the advanced concepts which they can take afterwards. So let us start with this machine learning fundamentals. We're having machine learning fundamentals. This is module 1, introduction to ML and its types. If you feel that by the end of this particular video, this is in fact the first one in the series, that this is definitely useful to you, you can subscribe to the channel, and then you will be getting updates on that. And in case you did not like it, or you are feeling that it is not useful, just give us your critical feedback so that we can just improve it. So I'm just going forward with this very interesting topic, kickstarting this web series today, which is machine learning fundamentals. Uh, First and the foremost question which is there: what is machine learning? And a very simple answer to this: machine learning is a branch of artificial intelligence. First of all, we need to be very clear of this. Machine learning is a branch of artificial intelligence that is enabling systems, not necessarily computer systems, but any system, any machine, to learn patterns from data. So, this is actually a science. Machine learning is a subset of artificial intelligence which is enabling systems, machines, computer systems, or some other systems to learn from data, because data will be having specific patterns. We are feeding uh, data into machine learning, and then definitely machine learning model gets prepared as per that particular data, and it is in fact without being explicitly using any kind of programming, or it is not programmed. So it is just taking data. It uses algorithms and statistical models to analyze data, identify relationships. So it is utilizing various algorithms, it utilizes statistical models to analyze data and identify relationships and make predictions and decisions. So, as you are feeding this huge amount of data into a particular machine learning model algorithm, so using a particular machine learning algorithm, it is able to establish and identify relationships, and based on that, when you are giving new data, it will be able to tell you what will be possible output of that data. So based on the earlier data, it can predict the output of the new data which is given to it. So it improves all the time as well. So when it gets exposed, so that means the system performance which is there, that means machine learning performance automatically enhances as it is exposed to more data and experience. So you can see this figure which is given beneath. We are having a problem, for example, and then we will be having data related to that particular problem. There are various phases it will be going through. For example, data cleansing is there, which is an important phase. We need to cleanse the data, correct it for any anomalies which are there, and then definitely feature engineering will be there. So we'll be going to data and see different sets, properties, characteristics of that is related to feature engineering. All of these different stages which are there, which you can see in this diagram, we are going to dissect and open them one by one as we move forward in this web series. Exploratory data analysis happens after this. So this is one more stage. And then data modeling, where in fact we are training the data. We are training the model. So we are training the machine learning model. So based on that model, we can have evaluation of that. So there will be in fact we're dividing it into training and testing data. So we testing model. So we're training the model and testing the model. So testing training data will be separately there. There will be testing data separately, on which we will test the model. And then there can be optimization and deployment. Definitely, it is a continuous improvement and a learning process. And then definitely that improvement and optimization can happen. And this completes this cycle which is given there. Very simple. Machine learning is actually a science, a branch of artificial intelligence, which completely depends on data. So it is a branch of artificial intelligence which is trying to establish relationships in a data. Without data, we cannot have machine learning at all. So as we are having blood in our veins and human beings are running on that, or our body is in fact dependent on that, we can just say data is as important for machine learning. Without that data, machine learning cannot happen. So machine learning is a branch of artificial intelligence. It is identifying relationships in the data which is fed into it, and then we are establishing different models, machine learning models, which are capable of then predicting and in fact predicting and identifying and deciding for the future data. When a future data is given, these models will be able to, or machine learning will be able to predict and give us the decision that what will be the possible outcome of this. So that is precisely what machine learning is. A model learns a relationship from, what is machine learning? A model is learns a relationship from examples, then uses that relationship on the unseen cases. So this is what is there. Data, we can have records, images, different kinds of data can be there. And then definitely patterns, relationships learned by the algorithm. What are the relationships there in the data? And then it is capable of making predictions. Machine learning learns a mapping from examples, then generalizes to new inputs. So it is definitely learning from the data, the mappings which are there, and then those patterns which are there, and then it can generalize those to new data, new inputs. So for new inputs, it will be able to predict and decide. Machine learning, in a very simple language, machine learning is a branch of AI in which algorithms improve at a task by learning patterns. So algorithms improve at a task by learning patterns from data rather than following only fixed and written rules. There are no written rules in this. As we see in the normal conventional programming, there will be some specific rules which will be implemented on the data inputted, and based on those rules, output will be generated. But in machine learning, there are no such rules. We are giving the data, and the machine learning model can improve as it moves forward with more and more data and gets more experience and more data. With that, it will be improving as well in taking decisions, future decisions, and predictions, making predictions. Simple example that we can give is give the model past study hours and exam scores after training. It can estimate the scores of a new student. So you are giving, for example, there's a relationship between the number of hours a student has studied with the result that a student has achieved. If we are having past data, for example, for 1 million students or half a million students, so that's the data with us, which is giving established relationship between, for example, the number of hours a student has studied and the outcome, what kind of result he or she got. For example, a student who studied for 2 hours failed. A student who studied for more than 5 hours, so or 5 hours, he has passed. Or, for example, a student who studied for 4 hours has passed. And then we can just say, feed this data into machine learning and establish a machine learning model. And that model will be then capable of predicting new, in fact, outcomes. It can estimate the score of new students. So that means now you will be just entering the hours, study hours of a student. It will be able to predict whether a student is going to pass or fail. It's a very simplistic example that we are giving here. In realistic, use cases or where machine learning is implemented, it is much more complicated, much more complicated than. So these are very simple examples to understand. Key phrases to repeat while, in fact, for the students would be learning from examples, not memorizing examples. So machine learning is actually learning from examples. It is not memorizing the examples at all. It's learning from those examples. So if, for example, this was the case there, how many cases of 4 hours of teaching has resulted in pass? So it's learning actually. Or might be having a situation where some of the 4 hours of student learning has resulted in fail as well, and it has resulted in pass as well. So it's for a machine learning model to then decide which numbers are more, or there can be some other parameters that can be considered, and it will be taking a distance. So this is basically learning. It's not just memorizing those values and outputting the result. No, it's basically learning. So learning happens there. AI versus ML versus deep learning. We know that artificial intelligence is a broader umbrella, and machine learning is a subset of artificial intelligence. And similar kind of thing is reiterated here. If you just see this particular slide, artificial intelligence is creating intelligent machines mimicking human intelligence. So it can have numerous ways to do that. There are various branches of artificial intelligence, and most of those branches have been explored to a greater extent, and we are having a lot of in fact outcomes, enormous benefits it is providing in different fields. That is there. But specifically machine learning, because we are more concerned here with machine learning. This particular web series is for machine learning, understanding ML, fundamental concepts of ML, basically, for someone who is new to machine learning. So machine learning is a subset of artificial intelligence, and it is actually algorithms enabling computers to learn from data. So as I told you, for machine learning, data is very important. Without data, we cannot do anything. So it is actually learning from data. Machine learning is a subset of artificial intelligence, which is which constitutes of algorithms, enabling systems, machines, or computers to learn from data, right? So then neural networks, definitely. Neural nets, deep learning, computational models, interconnected artificial neurons. In fact, that is a subset of machine learning. And then deep learning, neural networks with multiple layers for hierarchical representation learning. And that's definitely not a topic of discussion here. But in some other series, which is beyond, after this machine learning, we're having a different series which you can see, which is separately on deep learning and separately on neural networks. So, artificial intelligence, broader, in fact, area, which is where a subset of these different types of artificial intelligence is there. Machine learning being one of them, a major way to achieve artificial intelligence by learning from data. So that is machine learning, and then deep learning is a subset of machine learning. It is a subset of machine learning that uses multi-layer neural networks, often with large data sets. So, we will be more concerned in this web series about machine learning specifically. Traditional programming, as we discussed, it is rules, data, rules will be applied on the data and outcome will be generated. So, it is based on human specific logic, whatever logic has been given. So that is some general thing which we had been doing from many decades now, and that is we are inputting it, providing an input, and that is going through processing based on certain rules which are predefined rules, and based on those predefined rules they are applied on the data and then outcome is generated. So that is traditional programming, but machine learning is different. So what is there? We are having data which has answers, and that data which has answers inside it is fed to a model, a machine learning model, which gets ready, it gets prepared. The algorithm learns the logic from examples, so it tends to learn from the from the logic that is given to it. That means the data, it can be a huge amount of data, which is a quality data that can be fed into a machine learning model so that it learns, which has answers, in fact, specifically to a problem, definitely. So that it learns from there. Traditional programming, it's a programming writes the logic directly. If the score is 50 or more, it assigns pass. So this is a simple rule which is there. Machine learning is not, it does not provide these specific, you can say, logic, or you can say the rules on the basis of which the output will be generated. In this one, we provide past records and correct answers to the machine learning model. The algorithm learns a mapping automatically. So then based on that, algorithm is evaluating that what can be a possible outcome for a particular input which is there, and it is able to predict and definitely decide for the data, future data which is fed into it. And why this matters? Definitely, when the pattern is too complicated, it's too complex, you cannot create a straightforward logic for that. You cannot create a straightforward rule for that. So when it becomes very complex, handwritten rules become, fragile. They become expensive. That is true, and they become expensive to maintain. They become fragile and expensive to make. It's not easy to then, when the pattern is too complicated, the handwritten rules cannot work there. So it is machine learning is very useful in such situations, definitely. And as we know, we encounter mostly, if we just see the use cases or the normal implementations where we will be using machine learning, we see that patterns are very complex. It's not something very straightforward where rules can be created. There are three types of machine learning. I'll just quickly wrap the first this one. I hope that you're understanding the basic concepts. I'm keeping it very basic. There are three types of machine learning. Basically, if we just broadly classify and categorize it, supervised learning is there, which works on the label data. It predicts the output. Examples can be price prediction, spam detection. So price prediction of certain things or spam detection. It's working on supervised data. So if there are prices of the goods that is given in the past, and with the time the decrease and increase, how much decrease or increase had been there, we can easily predict what can be the price, for example, today, tomorrow, after 10 days, like this. So in the same manner, spam detection can happen in emails, where we'll be having emails which will be having certain signatures, signs, different kinds of signs, signatures. Based on those signatures, so they are labeled. So it can be labeled as spam. Previous ones which are there, they are labeled as spam and not spam, normal. And based on those, the machine learning model should be able to detect the future mails, whether they are spam or they are the normal mails. So, unsupervised is something which is not labeled. It discovers the structure of the data, and based on that, it is categorizing. There are various implementation areas for this as well. Clustering, anomaly detection can happen with this. So we are able to detect anomalies in the communication, in the data, or somewhere else. Uh, Reinforcement learning, one more type of machine learning, very important, which works on rewards and penalties, and learn a strategy. It is learning by doing certain things, and it will be getting either it will be getting a reward or it will be getting a penalty. If it is getting a reward, that means this is the thing which it needs to do in future as well, because it's a correct thing to do. And if it's penalized, that means this particular thing, it will be a learning that this particular thing should not be repeated in future, because this is something wrong, this should not be done. So very simple, in very simple words, I'm just telling. In fact, we are going to I'm going to correlate it to real world examples. In this particular series, the good thing is that we are going to have theory as well as the practical. We'll be learning the practical implementation, practical deployment of all of these different machine learning models, taking different examples and use cases. So where this can be implemented, reinforcement learning, games, playing, robotics, and all of those things. Supervised learning, coming back to supervised learning, there are two things, regression and classification. Very simple thing. If you're working with numbers, it's regression. For example, if I take the same example of the student's performance, if we know the study hours, we can just uh, predict the percentage of marks a student will be getting. That is regression. So it's in numbers, it's playing with numbers. Classification, on the other hand, we can have the categories. So if the attendance of a student is, for example, above 75%, we can say that the student is passed. So this is classification. If the student's attendance is less than, for example, 60%, we can say that this is a fail. Okay, so this is a classification, but this happens with the labeled data. So regression, predict a number. Classification, it predicts a category. So that's what exactly we have given here. House price prediction, student grade prediction, spam versus not spam, medical diagnosis. All of these are the categories that can be, in fact, that we can solve with supervised learning. And supervised learning in machine learning, if we just see, it's saying the similar example of these grades where students hours have been inputted, hours that a student has studied, and based on that number of hours studied by the student, the machine learning model is able to predict whether a student is going to fail or he or she is going to pass. So this is based on the data that has been fed into the machine learning model, based on which the model has been created. Unsupervised learning. Now we are having a different type, which is unsupervised. There are no correct answers. There's no label data in this. Typically, what happens in this particular type of machine learning is that we are having similar cases that are clustered together. For example, similar kind of data can be clustered together, so you can create categories of different. If you just see on the right hand side, there are groups which are similar, so clustering. So there are groups which are similar. They have been segregated. You can just see green with separate green, and then there is one with blue, and definitely one more. This one, three categories are there. This is basically on the characteristics of the data, on the patterns that have been recognized, and based on the data has been categorized. So similar clusters, similar cases. For example, segment customers. So you're segmenting customers. You're detecting anomalies. compress complex data. And definitely, for example, the segmenting customers, you are putting together customers which are having, which are spending, for example, per month more than, for example, 70,000, 80,000, or somebody, some customers which are spending, who are spending. So this is one of the aspects I am just giving. There can be different aspects on which categorization can happen. There are hidden structures actually of the data which we need to understand, as the learning thing which is there, the question which we need to ask, definitely, what hidden structures exist in the data. So there are hidden structures. There is no label on the data, but there are hidden structures. Those structures can be identified. They can be explicitly identified. Those can be highlighted, and based on those hidden structures, we can have different types of groupings of the data, and from there we will be able to understand, and decide. So anomaly detection is one more which can happen here. So we are able to detect anomalies in a transaction, because definitely the normal transactions will be looking different than the transactions which are having the anomaly. So we will be able to identify those transactions very easily. Uh, and the last one, certainly not the least, reinforcement learning is something which has been, implemented in a lot of very critical areas, and it has done wonders. Definitely, one of those areas is adaptive control, or we are having, for example, implementation of this in. We are having this, driving, auto driving, or similar kind of things, robotics, game playing. So it has been implemented there. It is actually the agent is doing some action on an environment, in a particular environment. So definitely there will be some, depending upon the implementation area. For example, game playing or robotics environment will be different. So an action will be taken, and then when it is done in an environment, it will result in two things. Either it will be a reward, that means the move which was there, that was correct, so correct move was taken, or it will be a penalty. So if it is a reward, that means similar kind of action should be taken in the future. So machine learning model is learning from there. Or if it is a penalty, again the ML model is learning from there, that this particular thing should not be repeated in future. So for example, we are saying that, learning learning the driving, for example. So if, for example, I am learning the driving, or somebody is learning driving. So if we are making a mistake, we are being penalized, and if we are doing something correct, we are being rewarded. And then from there we are learning that what is right and what is wrong, so that in future those mistakes we will not be repeating, and definitely the good things for which we got the reward, they should be repeated in the future as well. So this is reinforcement learning, very simple. Agent improves by taking actions, receiving feedback, and updating its strategy. So this is something which is very important, and this type of machine learning has been implemented at various domains, and it has done wonders. A machine learning workflow, if you just see, we are collecting data, preparing data, so that can consist of cleaning, encoding, and rest of things. We are training the model, as we just see. It's learning the pattern, and then we are evaluating it. We test it on some unseen data. So, and then we are deploying it. We use and monitor, and there is a continuous impact improvement. This particular thing goes on happening, and with this, the machine learning model matures. What is the point which we need to learn here is that, just the model training is not something, you know just that is very important. Although model training is something which is significant, we are not saying, we are not undermining or saying that, model training is, training the model is important, but data quality and quantity is as important, equally important as the training model. Preparing data is equally important. as we are having training models. So data quality and evaluation design matters just as much as the model training. So we are not saying that model training is not, but usually people are having focus, more focus on training the model. They are actually they are ignoring or undermining the necessity, the importance of data quality and data volume, which is there. They are undermining the importance of preparing data in an appropriate manner so that we are able to receive or get optimum results from a particular implementation, or when we are preparing, we are training a model in a particular a particular problem to address a particular problem. It is as important as training a model as we are having data collection, quality of data, volume, preparing the data in a appropriate manner, and its evaluation. All of these things are important. Moving forward, this example which we have given of students' performance, you can just see student data, attendance, student study hours, quiz scores, assignments. So this is some data which is pertaining to students. Normally this data is very huge. In fact, I have worked on a live student performance as well. I was a part of that. So it's a huge collection of data which consists of various features which can come in this particular data, and from there we can extract results, or prediction can happen for the future as well. So in as far as supervised model is concerned, it can predict fail or pass based on the final grade from historical labels. So it can predict pass, fail, or the final grade of a student based on the previous data which has been fed to it. Unsupervised, definitely it can also be used for the same example. Group students into learning patterns or behavior segments. It can group the students. So for example, I'm just providing very basic examples. They might not be that relevant as far as a particular problem is concerned, but they are relevant in understanding the things. So, for example, weak students, very weak students, average students, above average students, and excellent students. So, I'll be able to, in fact, based on certain previous this one, I will be able to categorize them based on the data pattern. So that will not be just one aspect of data only. When we have to categorize unsupervised learning without labels, it will be categorizing based on certain different aspects, that whether a student is weak, or it is average, or it is above average, or it is excellent. Someone is excellent. So reinforcement chooses the next practice. So we can decide, in fact, for the group of students which have been categorized, their behaviors, their patterns based on their behavior segments. So we can decide which particular learning practice is going to be more suitable for them. So this is what reinforcement learning can give us. And if we have to take the recap of this, what we have done, we have gone through machine learning, what machine learning is. And machine learning, definitely it's learning from the patterns which are in fact extracted from the data. Then we have gone through supervised learning, and it's using labels. Unsupervised, which is finds the hidden patterns and structures of the data. And then reinforcement learning, which is having, in fact, taking from learning from the feedback which is being given. It will be either a penalty, or it will be a reward. So it will be learning from there. And real machine learning requires a workflow, data, training, evaluation, and deployment. So definitely this workflow which is there, that is we have gone through that workflow as well, which is very important. And second thing is that what we will be taking in the next module. So this is module 1 of this series. We'll be going through, in fact, supervised. We'll deep dive into supervised, and there are, in fact, now next few of the modules which are coming. They are based on supervised. We'll be taking it in quite depth. We'll be discussing different kinds of algorithms that are there. regression versus classification in quite a detail. And then we'll be having evaluation metrics, accuracy, precision, recall. What are all of these things? Not only that, we'll be having, we'll be taking practical for this supervised learning in Python. In the next video, we go deeper into supervised learning and turn this intuition into a formal understanding, definitely. Looking forward for that. I hope that this video was very beneficial to you in understanding the basic concepts of machine learning. And we shall be continuing on this from the same point. We'll be starting where we left this particular video, machine learning series. This is a machine learning fundamental series. This was video 1, module 1, and we'll be moving towards module 2, where we'll be deep diving into supervised learning. Thank you so much once again for joining. In case you feel that this is going to be beneficial for you, please subscribe to the channel so that you will be able to know when a new video has been added. And in case you feel that this is not beneficial, you have been able to, there are, in fact, a lot of things, maybe some shortcomings in this, you can just give us a feedback so that we can improve our future future videos which we are going to put, or the series which are in fact coming in the same area of AI and machine learning. Thank you so much once again for connecting and listening to this. Thank you.